We're going to talk about inspiring engineering innovation. Now, Wahid sir gave a really good introduction about, how to bridge the gap between academia and industry. And that is exactly why I'm giving this webinar, so that students can at least start thinking from now on. You will not get the answers overnight, but once you start thinking, you will get the answers eventually along the way. Okay, so let's start with talking about what innovation is. Right, I have asked this question to so many students out there, and for them, majority it felt like innovation is something big, something what a genius would do. Right, everybody has those misconception. I would say it's a misconception. It has nothing to do with you being genius. Innovation has nothing to do with you being genius. There are so many small and innovative things which I'll also share later on. Those are all part of innovation. Okay, so let's start with what innovation is. So I believe that innovation happens when you start connecting completely different domains, completely different applications, your passion, your problems. When you combine and connect the dots between each of these things, that's when innovation happens. And innovation doesn't necessarily have to be a particular product. It could be a service as well. It could be like an innovative theory or an innovative strategy or even a process. Let's say you are studying together for your exams. Okay, that's one approach that you take, right? But you know what? You come up with a new strategy. How about one person studies this one concept? You distribute the concepts between different students, and then they teach each other those concepts, and that's an innovative way. It's an innovative strategy of studying. So that's also innovation. So anything new that you do, you find the problem, you see the domain, you find the passion, application, and then when you combine all of these things, that's when innovation happens. In 1980s or 1990s, I'm not sure about the exact year, but initially there used to be like pencils, the pencils that you write with, and erasers. They were sold separately in the market. Okay, there was just one guy who thought about, what if I could put an eraser behind the pencil? And that was a hit, right? That's also innovation. Innovation it doesn't have to be like bombastic, big innovation genius does. No, anyone can innovate. Trust me, anybody can innovate. Okay, so anything right from that example that I gave to anything that Elon Musk is doing, Tesla, SpaceX, and anything between them and even above or below them is innovation. Okay, so talking about how I created boarding pass for success, how I connected different domains. So I used my domain of engineering experience. I combined it with my passion of inspiring and speaking. Okay. And the problem is, like we talked about, the gap between academia and industry and also different learning strategies. So I have combined my passion, my domain, the problem, the application, and I combine that to create boarding pass for success. Okay, and yes, we have given seminars to over 3,800 plus students now in Gujarat, Mumbai, and now the first time in Chennai. So I'm excited about that as well. So we talk about inspiring and engineering innovation, the one that I have given right now, and I see also some of the students who attended my previous session are here as well. So that's awesome. And we also talk on robotics and the research applications on abroad studies and so much more. Okay, so what we're going to do is we're going to talk about different innovation hacks. Okay, like I said, how you combine different applications, domains, right, to come up with innovation or innovative ideas. First innovation hack. Let's start that by connecting concepts with applications. Okay, let's start talking about that. Now, I would like to ask the students, what do you see on the screen right now? What is this called that you see on the screen? Matrix. Somebody answered matrix. Matrices. Correct. It's a matrix, right? To be more specific, it's a transformation matrix, right? So I'm going to share this incident with you that happened with me when I went to University of Waterloo for my master's. So over there, you have to choose your subjects each term. It's upon you which subjects you want to choose out of like 20 subjects, right? So what I thought was, before I start my master's degree to the core with the core subjects, let me try taking the mathematics subject to brush up my calculus skills, linear algebra skills, right? So I was attending that class, and sir asked this question, like, what do you see on the screen, on the board? And we all said matrices, right? It's a matrix. And then he asked this question, which completely changed my perception of how I learned things. It completely changed my perception. What he asked was, where will you use this matrix? And I was like, okay, what sort of question is this? You give this to solve, I'll solve it. Because I never thought, where will I use this matrix outside? I mean, we would know some applications, but that's only because you are studying, right? That's why we know, okay, it's used here, it's used here. But what is like the direct specific application, right? So I would want to ask you, and you would know this, you know this somewhere. Where do you use matrices? Okay, specifically where? And do not shy away with like, I'm not going to judge you with your answers. Feel free to put out your thoughts out there. Okay. Okay, somebody mentioned image processing. Okay, awesome. Where else can you use matrix? Where else will you use matrix? To use as a secret code. That's awesome. Yes. Yes. For surveys, yes, that's correct. What else? What is the direct application? Okay, so you see all these answers that you gave, right? Image processing for surveys, right? Those are fields. Image processing is a field, right? Image processing is a medium, right, for certain applications. So I asked, what application will you use matrix for? All these things are subjects. All these things are maybe a vague idea, okay, for survey, but where in survey? Where do you see matrix being applied to a survey, right? So that's, I want you to go a step further and think. So I'm going to share with you two examples which completely changed my perspective, and I hope it does to you as well. Okay, so in robotics, you have these robotic arms, right? That you use robotic arms. So you use that arm to either rotate in a particular direction, right? Or maybe you will use that arm to move in a particular direction. Correct? So now we will see how do we use matrices to rotate the robotic arm or move the robotic arm. Okay, so as you can see over here, in the matrix, also we know that the first three columns of a transformation matrix are for rotation, right? We can say they are for rotation, and the last column is for translation, right? So what we can do over here is, okay, you see the first column, it says 1 0 0, right? Because the rotation is about x-axis, that's why you see over here it is 1 0 0. Now rotation is about y-axis, so that's why in the second column it is 0 1 0. And if the rotation is about z-axis, you guys did right, it would be 0 0 1 in the third column. So do you see a direct application of, okay, that's why we use matrices. Okay, that's why we use matrix. Do you see that aha moment? Oh, okay, that's why, right? So once you start understanding these sort of things, that's where innovation will emerge out of. So this is about rotation. Okay, next we can talk about translation. So basically moving in that particular direction. So that's why we use the last column. Okay, if you see the bottom three videos, because we want the arm to move in x direction, in the last column it is d100. Now similarly, if you want to move the arm in y direction, it is 0d10. And similarly, if you want to move in the z direction, it is 00d1. Does it make sense? Right? This is how you come up with innovative ideas, using matrices to move robotic arms. See, that's an application. I did not say matrices in robotics because that is still vague. Okay, robotics it's used, but where? Why will you use that? So I wanted to go a step further always when you study, because that's where you will get the right direction and the right content to understand things. Moving on, somebody mentioned image processing, right? So as you can see on the screen, there is this image from a CCTV footage. Okay, what do you see in the image? I know it is blurry, right? Can you tell me what do you see in the image? Can anyone mention what do you see in the image? Do you see a yellow circle? Do you see like a truck or something? Anyone? Some people? Okay, you see certain people on the screen, right? So two people having a fight, a thief, there are two guys, a person attacking another. Yes, yes, exactly. Plowing. Oh, that's interesting. Huh. It might look like they are plowing, but it's actually an image of two people fighting, right? You see there's a truck. So basically this image was taken from a CCTV footage in United States of America. Here you can see in the circle, you might guess that one person is attacking another person, right? So now, how we use matrices for catching criminals? Let's use that. Somebody mentioned image processing, correct? But now, where exactly in image processing will we use matrices? So that's where we will work on. Okay, so if you see on the screen on the left side, there is an image. Okay, now what is an image made up of? A pixel, right? An image is made up of pixel. An image is made up of thousands of pixel, right? Can we say each pixel represents a color? Right? It represents a color, right? And how can you represent colors? There are different formats where you represent colors, right? It's hexadecimal, RGB, correct? Okay, so basically you use an image. An image is made up of pixels, thousands of pixels. Each pixel represent a color. And each color can be represented in the form of RGB, hexadecimal, or even in the form of a matrix. Correct? So now what we have done here is, we have just done matrix multiplication. And with matrix multiplication, we received a blurry image. Correct? You use these filters on your phone, right? Where you use these, like on Instagram or Snapchat, use these different filters to blur your image or increase brightness, or something like that. So somewhere along that process, matrices are being used, right? So now, as we made the image blurry, we are using another process called edge detection, right? So if you multiply this image, like the matrices of these colors, with this matrix over here, you get an edge, you get an outline, like a black and white image with an outline. Okay, you see over here. So what these people did was, how did they use matrices to catch the criminal? Let's get back over there. What they did was, from the CCTV footage, they zoomed on the arm of the attacker. Okay, they zoomed their image over there. And they use edge detection on that very image on the right side, as you see. So what do you see on his arm? Do you see something on his arm on the right side of the image? What do you see on the arm on the right side in the edge detection image? A scar, a mark. Yes, it could be a scar, it could be a mark, correct? Some kind of tattoo, yes. So it could be anything. Some might say it's blood or some stone, could be a tattoo, a mark. So with further analysis, they got to know that this mark over here on his hand, it represents a mark of a tattoo, right? With the outline, they could understand that this tattoo is from a particular gang in California. They all have this sort of a tattoo, a rose tattoo or something. And then after further analysis, they got to know, they got to catch who the criminal was. So this is how they use matrices to catch criminals. Now, isn't that amazing? You go to a class thinking, "Oh, I'll study matrices today." How many of you are excited? How many of you are excited? "Oh, I'm going to study matrices today." But on the other, yeah, you might be a little bit excited. But on the other side, if I tell you, we are going to use matrices today to catch criminals. So how many will be more excited now, right? So it is all thinking about how to connect concepts with applications. So this is what we are doing right now. Okay. Now, I'm going to share with you Sherlock's strategy. I'm going to share with you a method. How many of you are Sherlock Holmes fans over here? Okay, there are many Sherlock Holmes fans. That's awesome. All right, so let's see how. Let's see a video of the Sherlock series. Right, I'm going to show you like the first 2 minutes of that series, and then we will discuss on that. Now the audio might not be audible, so but there are subtitles on the video which you can read.
When I met you for the first time yesterday, I said Afghanistan or Iraq. You looked surprised.
Yes, how did you know?
I didn't know, I saw. Your haircut, the way you hold yourself says military. Your conversation as you entered the room.
A bit different from my day.
Said trained at Bart, so army doctor, obvious. Your face is tan. With no tan above the wrists. You've been abroad but not sunbathing. Your lips really bad when you walk, but you don't ask for a chair when you stand like you've forgotten about it. So it's at least partly psychosomatic. That says the original circumstances of the injury were traumatic. Wounded in action then. Wounded in action, Santan, Afghanistan or Iraq.
You said I had a therapist.
Got a psychosomatic limp, of course you've got a therapist. Then there's your brother. You found expensive email-enabled MP3 player. You're looking for a flat share, you wouldn't waste money on this. It's a gift then. Scratch is not fine. Many over time. It's been the same probably as keys and coins. That's it. Next week we'll treat as one luxury item like this. So it's had a previous owner. Next bit's easy, you know it already.
The engraving.
Harry Watson, clearly a family member who's giving you his old phone. Not your father, this is a young man's gadget. Could be a cousin, but you're a war hero who can't find a place to live. Unlikely you've got an extended family, certainly not one you're close to, so brother it is. Now Clara, who's Clara? 3 kisses says there's a romantic attachment expense. The phone says wife, not girlfriend. It's a bit they're doing recently. This one is only 6 months old. Marriage in trouble then. 6 months old, he's just giving it away. If she left him, he would have kept it. People do sentiment. No, he wanted rid of it. He left her. He gave the phone to you. That says he wants you to stay in touch. You're looking for cheap accommodation, and you're not going to your brother for help. It says you've got problems with him. Maybe you liked his wife. Maybe you don't like his drinking.
How can you possibly know about the drinking?
Shot in the dark. Good one, though. Power connection, tell you the scuff marks around the edge of it. Every night he goes to plug it in to charge, but his hands are shaking. You never see those marks on a sober man's phone, never see a drunk's without them. There he goes, he was right.
I was right. Right about what?
The police don't consult amateurs.
Isn't it amazing? I love this series. I still keep watching that. Even if I watched once, I keep watching it. I really love Sherlock Holmes series and even the movies. So let's start with what did you see in the video? What could you make out? What did you observe? What was he doing? What was he doing in the video? No, the whole episode won't play. But if you want to, you should go and watch this online. You'll love it. But no, I won't show the whole episode. Yes, his observation skills, right? He was damn alert about things going on around him. Yes, correct. He was very alert. He was observing. Correct, right? So what he was doing is he was observing. What was he doing then? He investigated. Correct. Then what did he do? What was he doing? What else was he doing? He was connecting all the clues to come to a conclusion. Correct, that's correct. Observing, connecting, observe phone. Yeah, he saw the phone, there were scratches on the charging slot. So what he thought was that, maybe this could be a drunk man's phone, because only, no phone of a sober man would have such marks on it, right? So he was analyzing, he was judging. Yes, judging, a part of analyzing, correct. But what did he do before analyzing? He first observed, then he analyzed, right? But there is something that he is doing in between. What is he doing? Yes, he's observing. Yes, correct. He's like a detective. Yeah, he is a detective, right? So he's observing, he's analyzing, but there is one very important but a very simple thing that he's doing in between observing and analyzing. What could that be? Making out a story on his point of view. That is, again, that also comes under analysis. There is one simple thing. Thinking also comes under an analysis. Okay, so what he's doing is he's questioning, right? Questioning is a very simple yet a very powerful and effective thing to do. First he observed, then he questioned, because without questioning, you're not going to analyze, right? You're not going to analyze something if you don't question about that. Okay, do you think we can use a similar sort of strategy as an engineer? Imagine you're going to the class, okay, you are observing the professor teaching something, you observe the concept, but the next thing that we do is we start remembering the concept instead of questioning the concept. You start remembering because of exams, or you want to pass this subject, or it's important, it's fine. But at the same time, you also start questioning, okay? And it is normal if you don't do. Even I did not question during my college, but that is why I'm here, because this is what I've learned from experience. So I feel if I could pass on this knowledge to you while you are in college, it will create a big impact on how you think, right? So next time you go to a class or you study something, you observe and then start questioning. Okay, ask questions to your professor. I'm sure they will be more than glad to answer your questions. All they need from you is a little bit of curiosity and interest, right? Once you understand why these concepts are used, why these concepts exist, when you question that, then you will be able to think, okay, what next? Where can I use these concepts next, right? So question everything, right? Then what Sherlock did was, then he connected the dots, and then he analyzed, came up with a story, came up with a conclusion, correct? So try to use Sherlock strategy like an engineer, because I have seen so many students who think because of their past grades or results, they are not confident on their abilities, they self-doubt a lot, right? So what happens is, sometimes when you try to step into someone else's shoe, like, okay, what would Sherlock do in this situation? When you think like that, that's when you can come up with something innovative. But in the same way, you are also growing your own skills in that way, right? So try using this sort of a strategy like an engineering student, because you're a student right now. And I very well understand that it is not practical or feasible to question each and every concept, because there are hundreds of concepts that we study throughout your engineering life, right? So it is not practical that you would understand, you would try to use this strategy for all concepts. Maybe you can, maybe you cannot. But each and every stream has particular number of concepts which are very, very, very important and which you should know. And I have mentioned some of these concepts of each field over here. So no matter if you might not know other concepts, but there are some important concepts. Again, I'm not saying these are the only important concepts. These are just few examples of important concepts for each field. Now, these concepts are something which you should know, each and everything, A to Z of these concepts, right? So this is how you connect concepts with applications. This was the first innovation hack, correct? Now, let's talk about how you connect passion with what you study. Connect passion with engineering, right? There are so many students I meet, and it is sad to know that engineering is not their passion, and it is okay. It is okay. But then the sad part is they stop there. That engineering is something which I'm not passionate about. I'm just here to, pass my engineering degree, get a job, and so on. Right? So don't stop there. If you feel engineering is not your passion, it's fine. Engineering should not be your passion. Your passion should be something out there, some problem you want to solve, some cause that you want to connect with. And then you try to see how engineering can be used to solve that. Engineering should not be your goal. Engineering is just a medium to achieve your goals, right? So there's a very thin line of difference between these two, but it's very important to understand, correct? Let me give, make you understand this, giving some examples. Now, many of you might look at, okay, SHERLOCK strategy, and you saw, how matrices is used for catching criminals, for robotics. But then you'll be like, okay, that's great and all, but I don't care. I don't care about these things. How many of you feel that way? Because I surely did. When I was understanding things during my engineering degree, I used to question, like, I don't really care what I'm studying. How many of you have felt that when you are studying anything? That this is all great, these concepts are all great, but do I really care? Yes? Yeah. So that is where you use this innovation hack number 2, which is how do you connect your interest and your passion with engineering? Okay. How do you find that personal value? So let me give an example. How many of you here are from computer engineering or electronics engineering degree? Just write me so that I know that there are people from computer engineering background. Okay, there are a couple of them. Okay, so let me give this example. There is this one student. She's a computer engineering student, right? In her maybe second year or first year, or probably any other year. What she wants to do is she wants to make her neighborhood a safe place during COVID-19, right? That is what her goal is. Like, she's seeing we are living in pandemic times, and she wants to do something about it. Now, if it were any other student, she would think, well, this is not my job. This job is of a doctor, of police or government. What can I do in that, right? But what this student thought was, how can I use my skills and understanding of what I have to do something about this? Okay. So she thought, okay, let me make an app. Let me make a mobile app, so that people in my neighborhood or, or my family or society can know in which areas there are more number of affected people. So we don't go in that area. You must be aware of this app called Arogya Setu, right? That is this app that is being used in India currently for COVID-19, right? So she thought, how do I make a mobile app which can help us solve this particular issue, or how can I contribute to this? Then she thought, okay, what do I need to make this mobile app? So she thinks, well, I have to learn mobile app development. Okay. Then she thinks, what do I need to learn to know about mobile app development? So then she thinks, okay, Java, I need to know how to code. I need Java. Then she realizes that she already has this subject coming in her class that she's studying on Java or on coding. So now she is going to the class and she's studying because she wants to learn mobile app development, because she wants to make an app, because she wants to make her neighborhood a safe place. So do you see a direct connection between her interest, what her problem is, and the connection between engineering, right? So now she will want to go to the class. She will not say, well, I have to go to the class because, attendance or maybe marks or, I have to pass or something like that. So let me give these two examples, right? There is one student who's this first student who's going to learn Java because she wants to make an app. And there is this second student who is attending the class because, she has to attendance and all those things. Who out of the two will be more effective in learning that subject? Who out of the two will be effective in learning this subject? The first one, right? It's obvious that it would be the first one. So many people are saying they are learning Python. So that's amazing. Python can also be used to create so many applications, correct? So just replace that coding part. Instead of Java, use Python to create something related to your interest, right? So what I'm trying to convey here is this student will be more effective. It's awesome, right? Now these two students are going to for an interview. Again, who out of the two will be more effective? Again, the first one, right? Because the interviewer would think, well, this student learned code. Not only she learned, but now she implemented it for her own interest, right? So now the interviewer will think, if this student can make an app for herself, she can definitely use her coding skills to do something for the company. And now she will do it with more motivation because she'll be getting paid for that. Understand? So you have to sometimes also think like an interviewer. When you don't keep everything about yourself, think like an interviewer, what they would want from you. And this is how you connect your passion with engineering, right? Do you think this student might stop there? Do you think this app, if she creates, would it be only useful to her? No, it might also be useful for her neighborhood or everybody, right? Because everybody is living in COVID times. So if it is useful to her, it will definitely be useful to others. And that's how you become an entrepreneur, right? That's how innovation starts. Let me give another example of a mechanical engineering student. Who are mechanical engineering students over here? Just write yes or me in the chat. Any mechanical engineering students? Okay, there are many over here. Okay, awesome. So there is this mechanical engineering student who loves his grandfather. Okay, but with age, his grandfather gets a walking disability. Okay, so what this mechanical engineering student thinks is, how can I use my grandfather using my knowledge? If it were any other student, he would think, well, what can I do? This is the work of a doctor. What can I do in this thing? But this student thought differently. This student thought, okay, how can I use my skills? So he started researching on all these things. Okay. Okay, so now how many of you have heard about exoskeletons? Do you know what is an exoskeleton? Like a slight idea? Time travel machine. Well, you wish, but no. What is an exoskeleton? Exoskeleton. Any slight idea? Okay, so how many of you have seen Iron Man, the Iron Man suit? Right? That Iron Man suit is an example of an exoskeleton. Now, it will take decades for us to build that sort of a suit, right? It was way too advanced. But what I mean is, exoskeleton is anything that enhances a human's ability, for movements, walking, any sort of thing. Okay, it doesn't have to be a full suit. It could only be for your legs, or for your arm, or for your shoulder, anything to lift things or to move, for any such movements. So what this student thought was, this is something which is interesting, and it might help my grandfather with his walking, so he doesn't have to be dependent on his wheelchair, right? And electrical student might think, what, let me make an electric wheelchair so nobody has to, he's not dependent and he can move freely. There are so many ways to approach this problem. This student thinks, okay, how can I make an exoskeleton? And that's why he researches about this thing. Then he understands, in order to develop such a thing, I will have to understand statics, dynamics, or kinematics, right? And then again, like the first example I gave, he realized that he already is studying this, or already have studied this in his college. So now he'll attend this class because he wants to learn about exoskeleton, because he wants to help his grandfather, right? Now again, do you think, one, if he is successful in creating this, would it be helpful to only his grandfather? No, it is going to help so many people who have disabilities. So this is how you become an entrepreneur. Again, see, I'm not telling you to successfully make a product, but let's say this student is not successful in making an exoskeleton, or a part of it, right? But the approach, the journey he took to understand these things, to research about it, to gain these skills, that's not going anywhere. That's not going in vain. He'll be able to utilize all of these skills for something else, or for some other application. Correct? So don't think, this is not possible, this is not possible. It's okay. You don't have to make it possible. You just have to understand how can that be, how the approach can be, or make a software simulation of it, right? So don't try to restrict yourself just thinking, oh, this is not possible. Okay. Next, how many civil engineering students are over here? I can quickly give a civil engineering example. This student wants to do something, how to reduce water pollution. We see there is, this is a problem. There is water shortage, water pollution that's happening. So what this student does is, he thinks about, okay, how can I first understand the sources? What are the sources of water, right? He's starting from the root cause. Okay, what are the sources? Then he does a survey. Okay. Then he comes across this remote sensing image, and he realizes, what, if I use remote sensing, I'll be able to understand where are the different water sources. So now he has an elective coming up of remote sensing. So he thinks, what, I'll just take this course to understand this. See, again, connecting interest with engineering, what he's studying. Then he thinks, for all these things, the policies are made by the government. And do you think the government themselves make these policies? No, they need civil engineers who help them to make these policies. So this student thinks, what, let me go into this side. How can I be a part of it, so that we can, I can be involved in making these policies. And then he realizes, what, I'll have to understand urban infrastructure planning. Maybe I'll get a more idea there. So now he's connecting his subjects with what he wants to do, right? And there are so many different social causes that you could be connected to. As you can see on the screen, these are the sustainable development goals, like for no poverty, gender equality, climate action, life on land below water, and so many other things, clean water and sanitation. So you somewhere or the other, there would be some cause that would have been affecting you, or if not you, your society, your neighborhood, right? And the best part is, if you work on any of these goals, you are bound to receive more funding, because the whole world is working on these sustainable development goals. Now, I'm not saying everybody should have a social cause. Some people might not care about social cause, and that's okay. That's their own choice. So what is some other thing that they could do? Because it's cool. Engineering is cool because only engineers know how to implement their ideas into action. There might be people from different backgrounds who would know how to handle a business or anything, but we have the advantage because we know the resources, we have the knowledge on how we can create that simulated product into a real world product, right? And it's cool. How many of you have seen the movie Uri Attack? Okay, many people. Well, if you have not seen, try watching it. I love the sound effects of that movie, and I actually, no kidding, I watched it 3 times in theater with different people, but that's another story. But do watch it. And I really found this thing so interesting. There was this student in DRDO, intern, right? and he created this Garud bird surveillance design, if you remember, right? Did anyone have to tell him, "Ki, do design this product or something"? No, right? He did it on his own, because, and it's such a simple thing, like, because drones, the enemy might find out that, drones they are being surveyed, so they just use the design of a bird, which looks like so natural that they wouldn't doubt, if there is any suspicious thing going on. So such a simple idea, yet having such a powerful impact, right? So do things because it's cool. So yeah, any Harry Potter fans over here? Any Harry? Okay, there are many Harry Potter fans. Awesome. All right. So now, do you remember in Harry Potter movies, they had these newspapers, and when you open the newspapers, or the image, they used to move. It was like a GIF, right? If you recall that these newspapers were not stationary, they were dynamic. They had movements. So now we are going to use the app that we installed in the beginning of the webinar that I asked you to open that app. Okay, let me open it on my phone as well. Okay, just write a yes in the chat if the app is downloaded and you are able to open that app. When you open the app, you will see a camera being opened on the app. Just write yes if you are able to do it. Okay, there are few who are saying yes, and there are few who are saying no. So to people who are saying no, let's get on this in the end again. But for people who are saying yes, what I would like you to do is bring your phone, the other phone that you installed this app on, and point it out to this image that you see on your phone. Like if you see my phone, you can just point your phone on on this image that you see on the screen. What do you see? So people who are asking about the link, this was shared in the beginning. What I can do is, once we end the webinar, I'll share that link again, and you can replicate the same, reproduce the same scenario again. Okay, just write yes if you're able to see a video on your screen. The video is running real time like a GIF, exactly, right? So you get that feeling that you are reading a newspaper, how it was in Harry Potter movie, right? Now, isn't that amazing? Isn't this cool? Isn't this cool? And is this magic? No, this is not magic. Then what is this? What technology did we use here? So to people who are having trouble, who don't have another phone or video, it's not opening or anything, I'll share the link in the end, and I'll share this image, and you can try doing the same thing again after the webinar. Okay? Right. So coming back, this is not magic. In Harry Potter movies, this is shown as magic. But what technology is this? If it's not magic, what technology is this? You will have a slight idea, because you use it on your phones. You use it on Snapchat, on Instagram. No, it is not image processing. You think harder. There is something there. Yes, augmented reality. Somebody mentioned augmented reality. It is AI, right? You are using AI to create this sort of a thing. So you have already heard about sorry, not AI, AR. You're using augmented reality even on Snapchat, on Instagram. You use that app if when you point your camera on your wall and you can see snow falling. That is augmented reality, and this is exactly what we did over here. So do things because they are cool. There are so many of you who said they are Harry Potter fans, right? There are so many other things that you can be inspired from Harry Potter and try to think what technology they have used. Okay, so isn't that amazing? This is how you innovate as well. Um and this Okay, so this is from a series called Big Bang Theory. If many of you might be aware of the series, and this is Raj, the character Raj. He has like a magic wand sort of a thing in his hand, and what is he doing? He's trying to control the TV with that magic wand. He's reading instructions from a manual and doing those particular movements to maybe change the channel or switch on the TV or something. So here also people might have thought about this, well, magic wand, how can we use instead of a remote control, how can we develop something like a magic wand and, do certain actions, certain movements to control TV? That's innovation, right? So again, I'm not saying you have to make that product, but just, being aware that, something like this can be utilized as a remote control. That's what is something important, the way you start thinking, the way you get inspired, because we all watch these shows and we all watch these movies, but how to make the best out of them by actually questioning what are they doing, how are they, that is another thing. How are they doing is the next thing, but what are they doing, and connecting it with technologies, it's actually inspiring and it's fun doing those things. Yeah, so I had another friend with me in school. She was a diehard fan of Harry Potter, like literally. She had posters of Harry Potter and everything. And somehow, and she was average. Okay, she was not like a topper in the class or anything, but she found a way to connect her dreams to technology and make a career out of it. She's working as a visual effects in the VFX team of all these Hollywood movies. Like you can see on the screen here, like when the credits section come, the Crimes of Grindelwald. She was one of the team members in the VFX team. So you see, uh, what students do are they keep themselves restricted to their particular streams. If I'm from this stream, I can just do this, I can just do that. The industry, the world is moving towards an interdisciplinary approach now. So don't restrict yourself, right? Try to research and come up with all these different careers that are out there. If you love design, if you love VFX animation, there is also this career path to go towards. So the sky is the limit. Many of you must have seen the IIT people. They wanted to do their convocation, so they used virtual reality and 3D animation to do it, right? So this is made by a professor and their students. Now again, they had that personal value that this is our last year of college, we are not going to meet these people, we might not be able to meet these people, and because of pandemic we cannot have our graduation ceremony. So they created this virtual reality thing, where, and they also created a campus in that virtual reality environment so that they could go visit their friends, go to the rooms that they stayed in. Isn't this amazing? This is again connecting your interest with a technology, right? There are so many ways how you can do it. It's just dependent on you, how you see things, how your perspective is. So I'm going to share this example with you, which I really found very interesting. So there is this guy, I forgot his name. Louis, I think that his last name is Louis. So now on his face you can see there is this pipe, right, which he has on his nose. So you must have figured that he must have a medical condition, right? So what this person has is he has this condition called cystic fibrosis. The name isn't important, but what happens is in this condition that mucus is like jammed in your lungs. Because of that, you have trouble breathing. Okay, so let me play this video. So the only treatment here is that it's called chest physical therapy. As you can see on the screen that he has this in his lungs, the mucus is blocked. So, the airways are blocked. Now, the only treatment for this is chest physical therapy. As you can see on the screen, there is this one person who taps on your back. And it is a very painful procedure. And he has to go through it every time that he has an appointment. So then what happened one day was, now this guy was an electronic student, okay, and he also loved music. He was attending one of some seminar or some conference, and he was sitting in the audience near a loudspeaker. So now what happened was, when the speaker was saying certain words, we all know that each word has a certain frequency, right? So what happened was, at certain frequencies when he used such words, he started coughing. And this happened very regularly throughout his entire session. So then he realized that maybe, so because of this, he was coughing. That means the mucus in his lungs was getting separated, right? So then what he did was, since he was an electronic student and he liked music, he tried to come up with a product called frequencer. So all you have to do in the frequencer is, you keep that product on your chest. Oops, what just happened? Let me get back. Yeah, so you see the product. What he did was, you just have to keep that product on your chest. Because of the frequencies that are coming out, the mucus in his lungs was getting separated, right? And so he doesn't have to go through this painful therapy. And this is the way he became an entrepreneur, right? So he had this problem, like because he was an electronic student, he could come up with this sort of a product where just using the waves, the sound waves, he was able to come up with a solution for this, for his treatment. So now this is how you frame the solution based on the problem you have and the skills that you have, right? Now, many of you would say that, sorry, just give me a minute. Yeah, many of you would say that just because he was an electronic student, that's why he was able to come up with this product, right? But then when an interviewer was interviewing him, what he said was, what, if I was not an electronic student, I would still have this condition. I might have been a chemical engineer and I would have come with a medicine to cure my problem. So what I'm trying to say is, there are many approaches to solving a problem. Just because you are from a specific field doesn't mean you cannot take another approach or any other, or if a solution exists, it doesn't mean that other solutions wouldn't exist. So keep that thing in your mind. The last hack which I would like to share is the innovation hack 3, which is a Coca-Cola strategy. So this is very important. I want you to understand this concept really well. In 1990s, Coca-Cola was doing extremely well, but during that time, Pepsi came in the market and was giving it a tough competition. So now the board members of Coca-Cola, they gathered, to discuss how to handle this competition. So the CEO of Coca-Cola during that time, what he did was, he had this survey a survey done of Americans, where the question was, if they were thirsty, what would they prefer to drink? So majority of the people answered bottled water, juice, or tea, coffee, or other beverages. If you see in the survey report, in America, they use ounces. So out of 14 ounces, 12 ounces people answered for other beverages, and only 2 ounces were for Coca-Cola. Okay. So what the CEO thought was, our competition is not Pepsi. Our competition is our competition are these other beverages that are out in the market. So what he did was, he kept vending machines in each and every corner of the world. And even now, you might not be able to find clean water, but you will find Coca-Cola, over there. So what I mean to say by this is, even when you're going out for interviews or placements are coming, there might be thousands of applicants with you, but don't see those applicants as your competitors. Try to see the market, study the market, and because the situation is your competitor, right? Let's say your colleagues or your classmates have worked on particular projects, and you think, what, I should also do a certain project like that because they have done that. But the company might not want you. I mean, the company might not be interested in that product or your project. So what you have to study is the company, what they are doing, what are they interested in, and then work your way towards it. Don't try to study the other competitors. Try to study the company, what their goals are, and how can you contribute, how can you show them that you can contribute.